first slide on. Yeah. All right, good morning, everyone. This is our scheduled campus branch Wi-Fi talk. Again, we call ourselves campus branch wireless, but right now the only stuff we're working on is Wi-Fi, so we reserve the right to change it to wireless at some point. But when we get some small cells contributions into OCP, we'll change it to wireless. But right now, it's all about campus branch Wi-Fi and OCP. Next slide. So what is it about? Just a quick history. It's about a disaggregation at the edge. We're all very familiar with what OCP is doing in disaggregation at the hyperscale data center, and we're trying to bring the same philosophy and vision to the edge because all the benefits of disaggregation apply to campus branch and Wi-Fi equipment as well, especially now that people are putting more and more workloads on the edge. Edge computing is on its way. So we believe it's a time to, as a community, that move towards that direction anyways. So since the group started, subgroup started around like 2 years ago. In fact, we spent the first year talking about whether it belongs here or not. But eventually it started off as a subgroup in 2015. Since then, actually a lot of progress has been made. I'm surprised how much progress has been made. We have close to 5 open source Wi-Fi hardware choices available as of now, thanks to EdgeCore. They really led the way on the hardware contribution side. So we have around 3 Broadcom-based designs. They are Wave 1, Wave 1 MIMO, and then 2 Qualcomm-based designs. So those are all pictures you see there. The specifications are available on the link that's provided. Also, we have 2 hardware branch switches. A typical branch switch would be 1 gig 24 to 40 port switch. But the key difference is, since it's a campus branch deployment, they have PoE injection capability, which you typically don't expect in a data center. So these are, again, switches that are capable of injecting PoE so that you can power off your Wi-Fi access points. And then we also had software, obviously, initiative. We wanted to keep it very similar to the hyperscale side. So one of the key requirements was to actually have ONIE put on this so that the same workflows that you can you use in the data center can be applied here too, remote firmware upgrades, secure remote firmware upgrades, and all. So ONIE, as of today, and Sudhan is going to talk about it, ONIE is available on these units. Again, it's the same ONIE that you put it on the hyperscale network switches. And then for NOSes, again, we have, thanks to Mojo, at least there's 1 commercial NOS available for these Wi-Fi access points, and he's going to talk a lot about that. And then there is a community effort going on to have an open source, not just for proof of concept, and that work's going on as well. And then all these products that you see here are available in the OCP marketplace. So thanks to OCP for really leading the work. And again, the vision of this is edge compute is coming to the campus branch deployments. People are trying to put more and more workloads on the edge. Wi-Fi hardware is getting more and more. They have getting more and more compute. So ability to really put your workload, CI/CD infrastructure to put more, for example, firewalls at the edge. So people really want this sort of disaggregation, so the NOSes can be custom made. You can have dynamic networking scenarios, layer 2 overlays, layer 3 overlays, so which is really, so the same benefits of having a different and various networking configuration in the data center. You can actually imagine the same thing in the branch. If in anything in the branch is a lot more diverse. Some applications need layer 2 design, some need layer 3 design. You want, again, workloads like firewall right at the edge. So this really accelerates that kind of next world deployments where you really have very rich workloads. And what we see in the past, in a couple of months, some of the other hyperscalers like Amazon have started things like Greengrass, which is, again, their version of bringing compute to the edge. So I think it works very well. So at some point, we'll try to get something like that in our community as well. this one. And with this, I'll transfer to Sudhan. He's going to really talk about the commercial NOS. And the exciting part is we ended up dog fooding. The best way to check your, monitor your progress is, can you really use it, utilize it for your own good? So we ended up like dog fooding the CBW hardware and software at the summit here. So Sudhan's going to talk about it.
Thanks, Rajat. It's great to be here. So we're going to talk about OCP Wi-Fi at the US at the summit, and as we get into the talk, this reference to walk the talk will also become amply clear. So just before we start, a quick overview on Mojo Networks. So we are in the business of cloud-managed enterprise Wi-Fi. We are closing in on 500,000 access points shipped. A lot of our customers are brands that all of you should probably be familiar with. And we're bringing a solution to the market that we call Cognitive WiFi. And what we mean by this is a Wi-Fi solution that's intelligent, it's intuitive to use, it provides complete network visibility, which radically simplifies your network configuration, monitoring, troubleshooting, and we do this at massive scale. So this is the outline of what I'm going to present. So we're going to make the case for hardware-software disaggregation in Wi-Fi. Then we'll talk about the OCP Wi-Fi, which we have deployed over here. Then I'm going to go over what it's going to take for the adoption of open APs in the Wi-Fi industry. There are some issues that need to be discussed, some challenges there. And then we'll talk briefly about what we are doing as a company to bring about this change in the Wi-Fi industry. So coming to the case for hardware-software disaggregation, the key point is that access points really are no different than switches. They are sold as integrated systems pretty much by vendors. And the same OCP principles that have been applicable to Ethernet switches apply to access points as well. So there is vendor lock-in, and in fact, it's expensive to deploy access points. So it makes rip and replace really difficult and pretty much unfeasible. So the customers really don't have a choice once their hardware is bought and deployed. There is high margins on the AP hardware when the reality is that the primary value creation in the Wi-Fi ecosystem is actually coming from the silicon and the NOS. So there is really no reason to be paying these multiples of margins for the hardware. And the third one is that the incumbent vendors know that the customers are locked in. They have no choice. And so they're slow to bring features and benefits to their end users. They're taking advantage of the fact that customers have nowhere to go. And so the pace of innovation is not going as fast as it needs to be. And so we as a company firmly believe that open standards is the way to drive disruption in the Wi-Fi industry, and we're completely committed to this. And so obviously, with this philosophy and vision, we had a very good alignment with the Open Compute project. And we started getting involved with the Open Compute project a couple of years ago. So last year, we demonstrated an open access point from HCore. And we demonstrated a proof of concept of our NOS being installed via ONIE on that access point. We did this at Technology Day of last year's summit. And so after that proof of concept step, the next logical step was to think about actually taking this out into reality and actually showing to the world that this could happen. So we had this thought of why not use the summit as a showcase for demonstrating that this really works. So we bubbled this idea up. It went through CBW group, networking group, up to the OCP Summit Organizing Committee. And it was very positively received. And we got the go-ahead to deploy this solution at the summit this year. And so, this is what we have running in the expo hall today. There are APs similar to this. You will not see them in the expo hall. They're hidden away behind the partitions between the booths. But this is what is on the expo hall. If you've connected to these SSIDs at the expo hall, you've already been on the network. And yeah, we are serving around 3,000 guests who've attended the summit. And these are a couple of snapshots from our monitoring dashboard from yesterday. I think that peak count went up to close to 1,000 around lunch hour, I think. And there was a great collaborative effort between HWISW Networks, FN Tech, the company that's doing the audio-video network infra over here, the OCP Summit Organizing Committee, and the networking and CBW groups to make this happen. We've been having calls and meetings over the last 2 to 3 months to make this happen, and big thank you to all of them. And these are some more details of what we've deployed. So this is the open OCP accepted H-core hardware access point that's on which we have the ONIE partition and then as well as our Mojo NOS running on this AP in the expo hall. And we are planning to come out with a white paper soon, which will provide details of everything that we went through to make this happen, the lessons we learned, and then of course, where do we go from here, etc. So look out for that; it will be available soon. So now, like I said in the beginning, that I'm going to come to what it's going to take to drive, open APs in the Wi-Fi industry, and one of the key components that is really necessary to give the users the freedom of choice with respect to NOS is getting ONIE on the access points. And so for those who have come from an access point world and who might be unfamiliar with ONIE, I'm just going to give a very quick overview. So essentially, ONIE defines a dual boot partitioning mechanism. So there's a bootloader, one partition as ONIE, the other partition as NOS. And on first boot, the system boots into ONIE, where you discover, download, and install the NOS, and then you boot back into the NOS partition. And then that is your normal operational path until the time where you want to make any changes. So for example, if you want to uninstall your NOS, change your NOS, upgrade your NOS, or update ONIE itself, then you boot back into the bootloader, boot back into ONIE, make your changes, and then continue. So the ONIE repository, it basically consists of all this, the NOS installer, the discovery scripts, and that's all platform-independent functionality. And then there are mechanisms within the ONIE repository build system to add support for a particular platform. So that's just a quick overview of ONIE for those who are unfamiliar. And of course, primary adoption has been in the Ethernet switches world for an x86 UEFI-based ecosystem. And so we'll talk about what it takes to now take this same piece of software and put it on an access point. So, so with respect to adopting open APs in the Wi-Fi industry, there are three main issues that we need to talk about. So the first two are related to ONIE, and they have to do with the architecture and security. And the third one has to do with wireless certifications, which obviously is a non-issue for Ethernet switches. So these are some of the differences in terms of what CPUs are used in switches versus access points. There is difference with the bootloaders. And then secure ONIE is also going to be very essential for this to be embraced in the access point community, because the APs at the end of the day are out in the open. And so you cannot have, you have to protect the images, etc., that get installed on the AP, and you have to keep out malicious code, etc. So, so there are two approaches to getting ONIE on an access point. So the traditional approach is what happens in the switches world, which is you basically add your platform support to the ONIE repository. So the ONIE repository looks like this, and so there's a machine directory there, which has all the switches, and so you would add another access point platform at the bottom. So this is the traditional way of doing it, but so we are working, so we've been have explored this path, and currently we are working with chipset vendors to open source their patches and components of their licensed chipset SDKs in order to make this happen. That's obviously, it's not a quick process, but we are making progress on that front. So the second way of doing this is, so the first one was you add platform support to ONIE. The other way of doing it is that you add ONIE to your chipset SDK that already exists. So currently the way we typically can make like a vanilla software image for an access point is you take the chipset SDK, you typically get some platform board support packages from your ODM vendor, and that creates a vanilla software image. And so the change that we can make to this is you add an ONIE build option to this SDK build, and many times these SDKs are OpenWRT based, so it's easy to add like an additional package to that build. So you add the ONIE, the non-platform dependent ONIE components, and then that's another way to get an ONIE software image. So the advantages of this are there are no licensing issues related to the chipset SDK. This way is very scalable because as soon as the SDK is available for a new reference platform, then an ONIE build is available for it immediately. The hardware vendors are very familiar with the chipset SDK, so it lowers their adoption barrier. It makes it much simpler for them to create these ONIE images. And of course, it allows the ONIE development and the SDK, which is obviously two completely disparate things, to happen in parallel, and they're decoupled from each other. So just summarizing, so the first approach was to add the access point platform support to ONIE, and then the second approach is to add the ONIE build option to a chipset SDK. And the fact is that both of them can achieve different goals, and they could coexist. But finally, what we are trying to get to is basically this on an access point platform. So this is the like the flash partition layout on an access point like this. So there's a bunch of secondary bootloaders which are typically proprietary. The source code for that is not available from the chipset SDK. Then there is U-boot as a bootloader. There is also, APs also have this RF calibration data partition that you need to maintain throughout the lifetime of the AP, and it's unique to an AP. And then, of course, like we talked about earlier, there is the ONIE partition and the NOS partition. So coming to security, so this is from the current secure boot proposal based on ONIE, which in fact Kurt's presentation is going to start in a few minutes. So that proposal is based on x86 and UEFI, and a couple of fundamental things that it uses are UEFI applications primarily for managing keys. So this is the proposal that is out there for the switching world. And what we need to do is we need to take this and implement some kind of secure boot on the access point platform. So today what AP vendors do is they do implement some sort of verification of signed images on their APs. U-boot has supported verified boot starting 2013-07 version. So it allows you to basically make sure that your kernel is signed with the right key and things like that. And then the hardware or the AP vendors basically store their keys typically in like some kind of a one-time programmable memory, so that it cannot be altered. And there are also possibilities of leveraging mechanisms like ARM trust zone, etc., to further solidify this secure boot process. So the key challenge here is basically how do you manage the NOS vendor key database. So the current AP ecosystem basically assumes that you're just going to be running one type of software on, from one vendor on this AP. So now if you want to move to a system where a user can buy the hardware and then at a later point in time he's going to choose what software is going to run on it, then you need to find a way to maintain the keys, etc., that will enable you to verify the software, authenticate the software that's going to execute on the AP. So there are a couple of possibilities for managing these vendor keys. So one of them is we probably need to develop some kind of a key infrastructure system involving the hardware and the NOS vendors. Actually, there's a typo here. What I meant to say was the hardware vendor generates the root CA and programs the CA certificate hash, and then the NOS vendors get derived CAs from that root CA, and so some mechanism like that is possible. The other way of doing it is that we can port UEFI to this AP hardware software ecosystem, and then we can follow the same ONIE Secure Boot model that is being proposed, for the switching world. So UEFI in U-Boot is a work in progress by the SUSE Linux group. In fact, they presented recently at an embedded conference. But it's unclear whether, so their focus has actually been on making the boot process happen, but it's not clear at this point whether there is EFI variable support in the implementation that will be required for any kind of database management. And the other possibility is then UEFI on ARM. So far that has been targeted primarily for the server market. And that, in my opinion, would probably be a little too disruptive to the existing AP software ecosystem, because the chipset vendors put a lot of specific things in their bootloader and things like that. So to port all of that in and just migrate the whole thing to UEFI and ARM might be a challenge. So this is an issue, or we need to come up with some kind of an architecture to address this issue of security. And then coming to certifications, which again is a very unique thing to access points as compared to switches. So access points need regulatory certifications to ship. And so here is a possible solution that, of course, will require a lot of cooperation and collaboration between various entities. But probably OCP acceptance would have to include regulatory certification. The regulatory domain power tables published for an access point would have to be adopted by all the NOS vendors. But then we also need a fair model to distribute the NRE costs for getting certifications done. And another possibility to consider is that should we have like a ONIE for Wi-Fi, which includes the Wi-Fi subsystem in the ONIE build. So that would essentially have the regulatory domain tables and things like that. So it's like a template for the NOS vendors to replicate in their NOS images. So that's something to think about, and I think we're going to try and talk to Kurt and explore this possibility with him. So the FCC currently also does not support a model that recognizes hardware-software disaggregation. So they don't support this concept that there is hardware X, which is certified with software A, and then tomorrow the same hardware X might be running software B. Then the certification status of that AP, it's like a gray area right now. So that needs some, we need some clarity over there as well. And then like I mentioned earlier, that typically APs have this RF calibration data partition that you have to maintain throughout the lifetime of the AP through all your install, upgrade processes, etc. You cannot touch that partition. So, so having said, having talked about all of these challenges, at Mojo Networks, we are already, bringing these disaggregation benefits to our customers. So while we're doing our best to make progress on all these fronts with respect to driving open standards in the Wi-Fi industry, we are also doing what we can to already bring this to our customers. So open standards are a core belief of Mojo Networks, and they're also a fundamental piece of our business strategy. So this is not like a R&D project or something like that we are pursuing. This is actually, it fits into what we want to do to grow our business. So what we've done is we have made APs available at factory costs, and we are making no money on the APs. We completed this in April of 2016. So again, there's no margin on the hardware, and we got that out of our financials in December of 2016. And so the next step, which is why we are here at the summit and we're trying to promote this, is to collaborate with OCP, because our visions and philosophy is completely aligned with what OCP is trying to do. And then we're trying to leverage ONIE essentially to give end users the choice of NOS to install on the APs. And we're continuing to make progress on that, and hopefully we'll have more announcements about this in the near future. That's about it. So if you have any questions, I can take them. Thanks for your time. Yes, Jeff.
On the certification stuff, I wasn't really aware or not aware of how that works. So let's assume, oops, thank you. Let's assume we get all kinds of excitement after the summit based on our supplying the Wi-Fi access there. And if I was to ship a access point to a customer with ONIE installed, a binary image, because we can't open source it because of the driver issue, right? Would they be able to get a NOS from you and put it on this access point that I ship to them under my model number in a deployment because of the regulatory issues? Or how do we overcome that short term? Do we have to perhaps take the EdgeCore access point and create a SKU under Mojo brand for that? Or how do we move forward without this whole issue of these certifications?
So one possibility is that the AP would probably ship initially with the ONIE partition and the NOS from Mojo, and we would get that certified. And then the ONIE partition would allow the users, if at a later point in time they want to change that NOS, then so the model is open in that sense. So it probably ships with a pre-existing NOS, just because finally when the box ships, you have to have it certified. And so if you have ONIE in its current form, it has no Wi-Fi on it. So you cannot submit the box with just ONIE for certification. So currently you will probably have to put a NOS on it. But then the ONIE capability will allow the end user to switch that NOS at a later point in time if they so choose.
And also, Jeff, I think the precedent here is actually in FCC had that in front of them, because people were reflashing TP links, for example. They've been doing it for like years. And what they finally said that the owner of the network is finally responsible for making sure you maintain the RF envelope. So I guess what it comes down to is you first get the hardware certified for certain regions that we do, but in the end, after that, it's the NOS. The NOS, in conjunction with the person or entity who's operating the network, they're responsible for adhering to the rules and regulations.
And just a follow-up question on that in terms of the if there's ways that OCP can help with that. I'd be curious to hear, across countries. Is there something that the open source can do? Is there some sort of light, minimal NOS that can be shipped along with it to just provide, just enough functionality to show a login screen and get the commercial NOS and get through regulatory? Right. I'm not sure if there's you can think of roles for OCP.
The easier thing would be to just include NOS in the ONIE partition, or in the ONIE build itself, possibly. So we could extend the ONIE build to include so the AP is going to ship, is going to boot into the ONIE partition. It could just bring up like a very minimal Wi-Fi subsystem, just enough for you to do the certification. So that's a possibility of like an ONIE for Wi-Fi.
Yeah, I think that's most plausible.
Yeah, because I know we have a similar situation on the hardware switches. We run. This is sort of our own experience. We run our own NOS internal to Facebook, but then we're trying to find a minimal, lightweight NOS that the vendor community and the integrator and the optics community can use before it gets installed in our network, because we can't take our production system and put it out outside Facebook. So something in the open source, or if there's some lightweight version, that'd be kind of interesting.
Yeah.
So. Any other questions? So thanks a bunch, you all, and definitely credit for it. If anybody's been on OCP Wi-Fi, on the Wi-Fi during the summit, you're going through through stuff from our group, right, from the networking group. So it's super exciting. Thanks again to EdgeCore, to Mojo, to the CBW community. Please help me thank the speakers.
Thank you.